Supplemental math videos from Circle Christian School. Angle addition postulate. We can add angles together. Remembering that every angle has a measure, postulate number 3, leads us to postulate number 4. We can add the measure together. Let's find the measure of angle ABD and angle DBC. First, we have to do a little bit of geometry discovery. Remember that your first strategy is, of course, to draw a picture. Second thing is figure out what your givens are. And this is a little bit tricky here because this has a hidden given. They didn't tell it to you, but they showed it to you, that it has the red box here. And that hidden given is that this angle, this right angle, equals 90 degrees total. So from the top, A here, down to C, all equals 90 degrees. So we're going to figure out a little bit of the geometry that's in here. We know we can add two angles together to equal a whole angle. So that's what we're going to start with. We know angle ABD added to angle DBC equals the 90 degrees, the right angle altogether. So now we're just going to substitute the values. So we have a 2x plus the 12 plus x minus the 3, and it all equals 90. Now, when we put this into the algebra, it's not necessary to keep the degree values here. We just assume that there are angles and degrees and everything to begin with, but for practicality, we're just going to use real numbers. So we start with our fence of equality, and we're going to, there may be some distributing that we have to do, combining of like terms. We have to simplify first, and that's going to give us the 3x. And then we have the two constant numbers, 12 minus a 3, so we have a positive 9, and it's going to equal the 90. Now we have to isolate the variable here, get it all by itself using the additive inverse. So minus 9 and minus 9 is going to give us the 3x equals 81. Divide out the 3 or use some mental math. Get used to using a little bit of mental math here. And 3 times what will give you the 81? And you find that it's 27. So now that we have x, we know what x is, we can put it back into our original equations to find the measure of each of the angles. So the first one is going to be 2 times the 27 plus the 12 equals 2 times 27 is 54. Again, practice some mental math. 54 plus the 12, 54 plus 12, 54 plus 10 is 65, plus 2 more is 67. And then we have the 27, replacing it, minus the 3 gives us a 24. And so far we're not doing too well, are we? So I did some bad math somewhere. Should be 66. 54. Oh, it is 56. See? Now, here's what I did. When I got done here, I went, well, this isn't working right, because when I add these two together, I noticed that they don't equal the 90. So either I have something wrong with my other math, or I have something really bad that I did here. And hopefully you caught this one, because this can be a giant 10-pointer if you caught my mistake, that 54 plus 10 is 64 plus 2, 66, and this should be a 6. And yes, we add it together and it equals the 90. And all is happy in angel angle world. Another angle congruency is when you have an angle bisector. That 2 is a bit of a hidden given, that when you have an angle bisector, it means that the ray that cuts the angle cuts it into 2 congruent angles. So if you have 2 angles, then it means that to go and find the individual angles, that the first angle, that would be the measure of angle E, F, and H, would equal angle H, F, and G. Sorry, need a little angle out there. So that's how that congruency would be set up, and that's how you would set the algebra up. So look for some of those hidden things like the angle bisector, or maybe something equals 90 degrees, or that they tell you it equals something in your algebra setup.